Hello everyone, so this video is about the solutions of paper 1 of physics O-level January 2021. So let's begin. So the first question is about fill in the blanks. So as the atoms move towards each other, this is basically from astrophysics. As the atoms move towards each other, their kinetic energy stored increases, which increases the temperature. So basically the clue here is the temperature is increasing. So the temperature can only increase if the kinetic energy stored increases, because we know that temperature is directly proportional to the kinetic energy. That's why it's kinetic. Then if the temperature becomes high enough, nuclear fusion of hydrogen will start, and the star enters the main sequence stage of its evolution. So that's where it mainly starts from. Before main sequence, it was a protostar. So main sequence is where with the from the place from where the process actually begins. When hydrogen fusion stops in the core of the star will start to contract. So basically whenever the fusion stops, the heat stops as well. So when the heat stops, the heat was the reason for expansion. So if the heat stops, it starts contracting under the pull of gravity. This increases the temperature in a layer surrounding the core. Hydrogen fusion restarts in a layer surrounding the core. The star then starts to expand because the fusion reaction started again. That means it's getting heated up again, and if it gets heated up, it starts expanding again. So then eventually nuclear fusion stops in the core of the star, and the star explodes as a supernova. So that's the life cycle of a star, which is much larger than the sun. As you can see, it's a red supergiant, and if it's a red supergiant, it's going to be having a supernova explosion, and then it can either become a neutron star or a black hole. So then we move on to the next one. Average speed is distance by time, pretty obvious. Average speed is here, the distance is 6.5, and here they said that the camera takes 2 photographs of the vehicle 0.25 centimeters 0.25 seconds apart, sorry. So the time is 0.25 and the distance is 6.5 between the 2 photographs. So that's the average speed. The next one is you have to convert this speed into kilometers per hour to see if it exceeds the speed limit. The speed limit is 80 kilometers per hour, and by conversion we came to 93.6. So in here, meter is getting converted to kilometers by dividing this by 1000, because you're going from meters to kilometers, smaller to larger units. Same at the denominator. So denominator is per second, meaning 1 second. So if you're converting 1 second to hour, it is 1 divided by 3600. So that's what we got. The limit is exceeded. Then number B, this is explain how the graph shows that the lorry has a constant acceleration. So basically we get the acceleration from the gradient of the velocity time graph. So the velocity time graph gradient gives us the acceleration. As we can see, the gradient is the same at all points. So if the gradient remains the same, that means the acceleration also remains the same. Then we have to find the acceleration. Acceleration is v minus u by t. So in here, the final velocity is 24, starting velocity was 5, and the time taken is 60. So we got this much. Then number 3, give a disadvantage of connecting the bulbs in series. So of course in a series circuit, if one of the bulb develops a fault, all the other bulbs start failing. All of them, switch off. So just an advantage of connecting the light bulbs in series. So I basically give 2 together. The current remains the same at all points, in all the bulbs, the current remains the same. That's one advantage of the series circuit. And also they can be switched on and off together at once. So if you switch off one of the bulbs, all of them switch off. If you switch on one of them, all of them switch on together. So then voltage is current multiplied by resistance. Then current in each bulb is voltage by resistance. So voltage across each bulb is 33, and the resistance across each bulb is 390. So from here we divide them and we got 0.0846. Then energy is voltage into current into time, transferred to lamp X. So lamp X is basically the entire lamp containing all the 7 bulbs together. So voltage is basically the voltage of all the bulbs. In a series circuit, the voltage gets divided. So because there are 7 individual bulbs, the total voltage is actually the addition of all of them. So the total voltage is 33 multiplied by 7. Like I said, in a series circuit, the voltage gets divided. So we have to basically get the total voltage. Total voltage is the addition of all of them. So 33 multiplied by 7. Current is the same at all points. So current is 0.0846. Time it's in hours, 2.5 hours. If you convert hours to seconds, you have to multiply this with 3600. So we got this much. Then another decorative lamp Y uses 5 of the same bulbs in series. Both lamps are mains operated. Explain how the brightness of a single bulb in lamp Y compares to the brightness of a single bulb in lamp X. So both of them are connected to the main supply, and as we know, main supply is the voltage is around 220 to 240 volts. So because both of them are connected to the main supply, meaning both of them are being fed the same amount of voltage. And in lamp X there were 7 bulbs, in lamp Y there are 5 bulbs. Same bulbs, just 5, and in that X there were 7. So because we know that the voltage gets divided in a series circuit, in lamp X it got divided into 7 parts, in lamp Y is getting divided into 5 parts. So of course the divisions are lesser in lamp Y. So because the divisions are lesser, that means the voltage across each bulb in lamp Y is more. Because the divisions are less, meaning the voltage across each bulb in lamp Y is more. And what do we know voltage is? Voltage is energy per coulomb. So because more energy is provided to each bulb in lamp Y, that is why each bulb in lamp Y glows more than each bulb in lamp X. Then state which wire should the fuse be connected to, of course the live wire. Then state 2 electrical safety features which can be used in mains operated domestic appliances. There are so many of them. You can go for double insulation as well. You can go for earth wire. You can go for circuit breaker. You can go for so many of them. Power is voltage into current. Then power in here, we have to multiply the voltage and the current, which is 230 multiplied by 9.6. We got this much, and the unit is of course watts. Hairdryer contains a coil of wire which is used to heat air passing through the hairdryer. Explain why the coil of wire heats up when there is a current in it. So basically whenever current flows through a wire, it goes through resistance as well. So whenever it goes through resistance, it faces difficulty in moving forward. So this means not all of the energy is used by the charges to move forward, but rather some of them is used to overcome the resistance. So because you are losing some of the kinetic energy in overcoming the resistance, that means that energy which is lost in overcoming the resistance is actually lost as heat energy. This is why this thing heats up. So because the current flows through the resistance, there is difficulty in moving faster forward. That means not all of the kinetic energy is used up in moving forward. Some of it is used in overcoming the resistance. This results in heat energy being produced because of the resistance having to be overcome. Explain how a fuse protects a domestic appliance. So fuse is basically a cartridge containing a thin wire inside of it. When current above a certain rating tries to flow through the fuse, the wire heats up and melts. The wire inside of the cartridge, it melts. So if the wire melts, that makes the circuit incomplete, prevents further flow of current, and hence protecting the appliance. Then give a safety precaution that would reduce the teacher's exposure to radiation. So the teacher can wear a deadline suit, that's the best one, and also can wear goggles, gloves, all the safety precautions, and also can use tongs if needed. Can also use tongs. There are many of them. Tongs to hold the substances, the radioactive substances. If the technician uses tongs, that would be better instead of holding it by hand. Neutrons are basically 226 is the mass number and 88 is the atomic number. So if you decrease the mass number, the atomic number from the mass number, you will get the number of neutrons, 138. Name of a piece of apparatus that detects ionizing radiation, of course GMT with a counter. Then the teacher is saying that the detector cannot detect the radiation if the detector is moved 5 centimeters away from the source. So just by taking the detector 5 centimeters away from the source, the detection stops. That means what? That means it is something which gets very easily absorbed by air. The only thing that gets so easily absorbed by air is alpha. Then half-life, it's the time taken for half of the initial radioactive isotopes to decay away. Pretty easy definition. And here they're saying the half-life is 1600 years. That's mentioned in the question. And they're telling us that how many atoms are you expecting to remain after 800 years. So 800 years is basically half of 1600. So if half-life is 1600, we are basically having half of half-life. We're basically having half of half-life. So that means if 1600 years is the time taken for it to become half, 800 years, in 800 years it will not become half, but rather it will become, it will basically be left with 3/4 of the total amount, because out of the total amount, half of the half is going away. Half of the half is going away. So half of half means what? 1/4. So out of the entire thing, only 1/4 is decaying away. That means we are left with 3/4. So if we multiply 3/4 with the initial amount, we will get 1.995 into 10 to the power 21. They asked for an approximation. So the only value which is coming close to 1.995 into 10 to the power 21 is 1.88 into 10 to the power 21. Okay. Then when a rubber ball is dropped, it hits the floor and bounces. Design an investigation to determine how the temperature of the rubber ball affects the maximum height it reaches after it bounces. How to change the temperature of the ball. You should refer to how to change the temperature of the ball. So we are changing the temperature of the ball by using a water bath, because we don't want to provide direct heat to the ball. We use a water bath to provide indirect heat to the ball. Okay. That should always be the approach. You should never apply direct heat to any substance, because that would result in expansion of the substance and maybe even the shape of the substance may change if you apply direct heat. Then the variables that need to be controlled, of course, the height you're dropping it from has to be same for all the, for all the experimental readings. And also you have to make sure that the ground on which you are dropping it remains the same. The ground shouldn't change, because if the ground changes, the height to which it bounces back will of course not be the same. How to obtain high quality data? So we had basically obtaining two kinds of data, one of the temperature, one of the maximum height. So I wrote that several values of measurement of height are done using a very precise measuring tape. So if you use a very precise measuring tape, what are you going to get? You're going to get values of height up to the best of decimal places, closest of decimal places. You're going to get the values to if you use a precise measuring tape. That's what we want. And the experiment has to be repeated several times to get the average values. This should be average values, sorry, average values. And to get the average values, of course, you need several values of temperature as well. The temperature value, you shouldn't just take it once. You should take different values of temperature, and based on different values of temperature, then you have to drop the ball, and then you get the heights to which they bounce back. So of course, the first thing that you should do is get different values of temperature by heating the ball. So how do you get different values of temperature? If you heat the ball, temperature rises more if heated for longer. So if you heat the ball for longer, you will get greater temperature rise. If you heat the ball for shorter amount of time, the temperature rise will be lesser. Then this is a pretty easy one. This is the south pole, and of course, if you want to make a uniform magnetic field, you have to have the opposite pole facing it. So south's opposite is north, so that's the pole which is facing this one. And of course, because it's a uniform magnetic field, that means the field lines are equidistant. If you look at this field line and this field line, and the distance between this field line and this field line, and the distance between the next two equal, and this equidistance is maintained between all, between every two field lines throughout here, right? That has to be maintained. That will give you the 3 marks. And the direction, of course, the direction has to be from north to south. Okay. And then they're asking us, explain why the iron ball experiences an upward magnetic force. So basically, the iron ball is a magnetic material, right? So when the iron ball lies within the magnetic field of the magnet, a north pole is induced on the top half of the ball. Sorry. So on the top half of the ball, you'll get a north pole. Why? Because that's induction, magnetic induction. So because the south pole is at the bottom of the magnet, because the iron ball is now within the magnetic field of the magnet, a north pole, I mean a pole of opposite polarity as compared to the bottom of the magnet, will get induced here. So because opposite poles attract, that is why the ball will attract to the south pole of the magnet. Then I'll draw a labeled arrow to show the weight of the iron ball. Weight has to act downwards, of course. And they're telling us the iron ball experiences an upward resultant force. That means the upward force is more than the downward force. That means your weight has to be represented by an arrow which is smaller in length as compared to the magnetic force. Why? Because the upward force has to be more. And we know that a vector is represented by its direction as well as the size of the, the length, the size of the length. So if the length is more, that means the value is more. If the length is small, that means the value is less. So because the magnetic force is larger in value, its length should be more. And because the weight is smaller in value, its length should be less. Then weight is mass into gravitational field strength. And from here, they have given us the information that the resultant force acting on the ball is 124 and the magnetic force is 165. That means this magnetic force is 165, but the resultant force on the ball is 124. And what do we know resultant to be? Resultant is basically resultant is basically found after you subtract opposing forces. So resultant is upward minus downward. The resultant is, of course, upward. It's moving upward, right? So the upward force would be more compared to the downward force. So that's why the resultant is upward minus downward. So resultant in here is 124 millinewton. So it's 10 to the power minus 3. And the upward force is the magnetic force, which is 165, 10 to the power minus 3 minus W. That's the weight. The weight came to this much. And if I wish to find the mass is weight by G. So this is what I got. Explain why the resultant force acting on the iron ball increases as the iron ball moves towards the magnet. So if you move towards the magnet, what do we see? If the ball moves towards the magnet, that means, what do we know? That if you move close to a magnet, the field strength is more, because the greater the distance is away from the magnet, the weaker the field becomes, and the closer you are to the magnet, the field strength is more. So if the ball gets closer to it, this is the, attractive, sorry, the attractive force increases due to decrease of distance. If the distance of the, distance between the ball and the magnet is decreasing, that means the attractive force will increase because the field strength is becoming more. So this means what? The upward force becomes even larger than the weight. Of course, the upward force is already larger. Now it becomes even larger than the weight. And because we know the weight doesn't change, the weight remains constant. That means because the upward force is constantly increasing and the downward force is constant, that means the net force overall upwards would increase even more. Number 8, they're showing two different graphs: pressure versus temperature in degrees Celsius and speed versus temperature in degrees Celsius. Give a reason why the student does not start the y-axis from 0. So y-axis represents what? Pressure and mean speed. So we know that pressure and mean speed can never be 0 unless they reach 0 Kelvin. That is the only point at which they will be 0. Otherwise, they will never be 0. Describe the relationship shown by the graphs. So if you look at the first graph, it's a linear graph, of course. We can see that the greater the temperature, greater is the pressure, and the relationship is linear. It's a straight line. And for the second one, greater the temperature, greater is the mean speed, but the relationship is non-linear because the graph is non-linear, right? That's the answer. Then explain why the value of temperature chosen in the simulation should not decrease below -273. So -273 is what? It's a very special temperature. It's called 0 Kelvin or absolute zero. At this temperature, motion of everything stops. So if motion of everything stops, there is no more point going below it, because at -273 everything has stopped moving. So there is no point going below a place where everything has already stopped moving, right? Then using the curve of best fit on graph to determine the mean speed of a gas when the gas temperature is 100 degrees Celsius. So we use the second graph, and if we zoom in, we will be able to see that at 100 degrees Celsius, the temperature is 520. Sorry, the mean speed is 520. At 100 degrees Celsius temperature, the mean speed is 520. So that's what we got. Then they're asking us to find the average kinetic energy with the temperature is 100 degrees Celsius. So the mass is given, and to find the kinetic energy, we need the velocity as well. And we found the velocity in the previous part. At 100 degrees Celsius, the velocity is 520. We put it here, we get the kinetic energy. Calculate the temperature of the gas in Kelvin when the temperature is 100 degrees Celsius. So whenever you wish to convert degrees Celsius to Kelvin, you simply add 273. You simply add 273. That should give you the temperature in Kelvin. That's what we got. Then you have to basically complete the graph, average kinetic energy versus temperature. Always, we have to understand, we have to keep in mind, average kinetic energy versus temperature will always be directly proportional. The average kinetic energy is always directly proportional to Kelvin temperature, and that's why it's always going to be a straight line through the origin. Okay. Then number 9, some of the light is reflected from the surface at the point A. So at point A, some of the light is reflected. So this is basically the reflected ray. Sorry, some reason it's got caught over. Just a moment, let me just draw it again. So yeah, this is the reflected ray that we get at point A. Okay, and then that's it. This part is done. The next part is, and you have to make sure that the angle of incidence here is the same as this one, because angle of incidence has to be equal to the angle of reflection. So the reflected ray, the angle it makes with the normal, has to be equal to the incident angle. Okay, then you have to use a protractor to get this value, angle of incidence, and this value, angle of refraction. You have to use a protractor to get it. So it comes to 60, the angle of incidence, and 31, the angle of refraction. Then we use these two values to find the refractive index, which is sine I by sine R. Okay, then describe how the student could improve her investigation to obtain a more reliable value of the refractive index. So this is where the graph comes into use. So you have to basically take many values of angle of incidence by shining the red light at different angles of incidence. So many different values of angles of incidence will give you different values of angles of refraction, the corresponding values. So we have to then record these values down, angle of incidence values, angle of refraction values, in a table, and from that table we have to then record those results. Sorry. Then using those values, we have to then plot a graph of sine I versus sine R. Okay, we have to then plot a graph of sine I versus sine R, and the gradient of the sine I versus sine R graph will give us the refractive index. Okay, this question it's telling us that now they're using blue light rather than red light. This is the red light's path. the dotted line, we have to complete the blue light's path. So basically they're telling us the refractive index of flint glass for blue light is higher. So the n value, the refractive index value for blue light is more. So if we manipulate the equation a bit, we get n is sine I by sine r. From here, r is sine inverse of sine I by n. So if n is more, if the denominator is more, in here, if the denominator is more, that means the angle of refraction would be less. So because they're telling us the refractive index is more for the blue light, that means n is going to be more. That means the angle of refraction is going to be less. That's why if you look carefully, compared to the red light, the angle of refraction for the blue light is lesser, right? And then the usual path follows. The usual path is, it goes here, and then when it's about to go back to the air, it bends away from the normal. And you have to make sure that these two lines are parallel. The red light's path in air and the blue light's path in air they have to be parallel. The paths have to be parallel, right? That's it. Then number 10, the bar of the hurdle is made of wood and it's painted black and white. The temperature of the hurdle increases when the sun shines on it. Explain which part of the bar reaches the highest temperature. So basically, the black part of the bar reaches the highest temperature. This happens because black surfaces are better absorbers of heat than white surfaces, right? So that's something we know from radiation, that black surfaces are always better absorbers of heat than white surfaces. That is why the black part of the bar will reach a higher temperature when exposed to the sun. Then the air near the bar receives energy by heating. Explain how convection current is formed in the air near the bar. Which, okay, keeps repeating, just a moment. Okay, so basically we have to describe convection currents over here. So the black parts emit a lot of heat after absorbing a lot of the heat. So the ones which absorb a lot of heat, they also emit a lot of heat, right? So the black parts, after absorbing a lot of heat, they start emitting the heat to the outside. This heat is then transferred from the bar to the air by conduction, right? Conduction is the process by which the heat is transferred from the bar onto the air. So after this conduction, this warm air being lighter rises, while cooler, heavier air from the top comes to take the vacant place. So warm air, because it's lighter, less dense, it's going to rise, and cooler air from the top, which is heavier, will come and take the vacant place, right? That's what I wrote. This results in a convection current. Current is what? Current is movement. So convection current means movement of air, warm air and cold air, which keeps repeating. Okay. Last question, number 11. Here they're asking us to find, in this bottle they have put water, and they're finding the volume of the water that's been put in. So to find the volume of the water that's been put in, we have to basically make use of this formula. Volume is mass by density. So the mass of the water they have found using calculation. So mass of the empty bottle and the stopper is 63.4, but with the water inside, the mass becomes 112.9. So the mass of the water only is 112.9 minus 63.4, which comes to 49.5. That's the mass of the water only. And we know the mass of the water, we also know the density of the water, so we divide them, we get volume of water to be 49.6. So 49.6 centimeter cubes of liquid is necessary to fill the bottle. Full bottle will only be full if you have this much of fluid inside of the bottle. So this part was only to get the volume of liquid necessary to fill the bottle to its top. Okay, in the next part, this is the part where we actually find the density of the unknown liquid. That is our main question. So the volume of liquid when full is 49.6, of course, that's what we found here. The mass of the liquid is, once they fill up the bottle with this liquid, it rises to 143.8. The mass rises to 143.8, and the mass of the empty bottle was 63.4. So we do the same thing over here. We get 80.4 grams. That's the mass of the liquid only, the unknown liquid. So density is mass by volume. Mass is 80.4, and volume when it's full is 49.6. So we got the density to be 1.62. So this is the last one. The measuring cylinder, another student uses a measuring cylinder to find the volume of the unknown liquid. Discuss the advantages and disadvantages of using each method to find the volume of the unknown liquid. So you can either use a measuring cylinder to measure volumes, that's pretty obvious, or you can use this method. So what are the pros and cons? The measuring cylinder does not need to be dried. In here you could see, insert the stopper and dry the outside of the bottle. They are maintaining this. They are drying the bottle again and again. See, again drying. They are drying the bottle again and again, because if you don't dry, the residue that's left with the water that's left behind is going to add to the mass. That's why you have to constantly dry it. The measuring cylinder doesn't need to be dried again and again. The problem with the measuring cylinder is there could be parallax errors while reading the meniscus. So there is a, whenever you have a, you know, measuring cylinder, what do you get? You have this lower meniscus of the water. You have to read it properly at eye level. So there could be a problem, parallax error problem while reading the meniscus. The bottle allows us to get the volume up to 1 decimal place. The bottle is something, if you look carefully, we got the volume up to 1 decimal place. So that's an advantage of the of using the bottle rather than the measuring cylinder. So these are these few of the advantages and disadvantages. You can go for others as well. There are other options as well, but I gave these ones. So 3 marks. So I gave two advantages and 1 disadvantage. 2 advantages, 1 advantage of measuring cylinder, 1 advantage of bottle, and 1 disadvantage of the measuring cylinder. So that's the end of this paper. Thanks for watching.